SpaceX aims for record-breaking turnaround with Starship Flight 8. SpaceX is pressing ahead with its ambitious Starship program, targeting a launch for Flight 8 potentially as early as next month. This follows the successful conclusion of Flight 7, a mission marked by both achievements and challenges. Elon Musk, in a summary of Flight 7, hinted at a swift turnaround, suggesting the next launch could address unresolved issues like heat shield performance and the PEZ payload dispenser. A follow-up tweet further solidified this timeline, putting SpaceX on track to launch Flight 8 in February. This rapid turnaround, if successful, would be a significant milestone for SpaceX, mirroring the speed achieved between Flights 5 and 6. Such a feat would mark a substantial acceleration in the company's launch cadence. The confidence in this ambitious schedule stems from significant preparations already underway. Starship 34, having completed cryogenic testing, is slated for engine installation and subsequent static fire testing at the Massey test site. Simultaneously, Booster B-15, also undergoing engine installation after completing its cryogenic tests, is poised for deployment. The recent movement of Starship 34 to the Massey test site, coupled with ongoing activities related to Booster B-15, strongly suggests a near-term launch window. Critical to maintaining this pace is the condition of the launch pad infrastructure, which post-Flight 7 assessments have declared to be in excellent condition. The launch tower, QD system, water deluge system, protective wall, and tank farm all exhibit satisfactory performance levels. Notably, the communication antenna, which experienced issues during Flight 6, has shown significant improvement, a crucial factor in the successful catching attempt during Flight 7. This indicates a comprehensive readiness that could allow for a swift transition from one flight to the next, potentially requiring less than a week. Such operational efficiency represents a crucial step towards SpaceX's goal of accelerating Starship launches, further solidifying its leadership in space exploration. However, this rapid pace hinges on FAA approval and resolution of any outstanding issues stemming from the recent Flight 7 incident. SpaceX's infrastructure and systems show improvement ahead of Flight 8. SpaceX's preparations for Starship Flight 8 are demonstrating significant progress, with enhancements to critical infrastructure and systems following the conclusion of Flight 7. Post-flight assessments indicate the launch pad infrastructure, including the launch tower, QD system, water deluge system, protective wall, and tank farm, are all functioning optimally. This suggests a well-prepared launch environment for the upcoming mission. A key improvement noted in the assessment is the significant advancement in the communication antenna system. The antenna, which experienced problems during Flight 6, has undergone improvements that were crucial in enabling a successful catching attempt during Flight 7. This upgrade highlights a proactive approach to addressing identified issues, improving overall reliability, and potentially reducing the risk of similar problems during Flight 8. The assessments also indicate that critical systems are in excellent working order, enabling the rapid turnaround time planned for the next mission. This readiness is underscored by the smooth transitions between flights, with recent movements of Starship 34 and Booster B-15 to the Massey test site, demonstrating a streamlined process for transitioning between missions. The swift movement of Starship 34, coupled with the ongoing preparations for Booster B-15, suggests a high degree of efficiency and coordination within the SpaceX operations. Furthermore, SpaceX's proactive approach to issue resolution is evident. The company is actively working to determine the root causes of the recent incident during Flight 7, including the explosion, debris fall, oxygen leak, and fire in the AFT section. This direct engagement with the FAA, crucial for gaining approval for Flight 8, demonstrates a commitment to transparency and thorough problem-solving. The fact that no injuries or significant property damage have been reported further underscores the dedication to safety and responsible operations. This combination of operational readiness and proactive problem-solving positions SpaceX to navigate potential FAA scrutiny effectively and launch Flight 8 efficiently. Regulatory scrutiny mounts for SpaceX as Flight 8 approaches a shifting landscape. SpaceX's pursuit of rapid Starship launches faces increasing regulatory scrutiny as Flight 8 draws nearer. The recent incident during Flight 7, including an explosion, debris fall, oxygen leak, and fire, has prompted a mishap investigation by the FAA. This scrutiny is likely to impact the launch timeline for Flight 8, adding a layer of complexity to SpaceX's ambitious schedule. The investigation follows a trend of regulatory scrutiny for SpaceX, raising concerns about the pace and potential oversight of the FAA's regulatory processes. Recent comments from Congressman Shane Duffy and Senator Ted Cruz highlight potential shifts in FAA policy toward commercial space ventures. Their concerns extend beyond the recent incident, encompassing broader issues related to launch license violations and the perceived slow pace of regulatory procedures compared to SpaceX's rapid development and operational tempo. This concern is amplified by past instances of fines levied against SpaceX for alleged violations during Falcon Heavy missions. The public debate about FAA regulations, particularly its approach to licensing and oversight for commercial space ventures, is becoming increasingly visible. Discussions surrounding potential changes to FAA fine policies, perhaps favoring SpaceX's rapid development, are part of this evolving landscape. A potential separation of the FAA's Office of Commercial Space Transportation, AST, from the FAA is also being discussed, aiming to increase the office's ability to issue licenses more swiftly and operate with greater independence. This potential restructuring, though not yet confirmed, could significantly impact the regulatory environment for SpaceX. The evolving dialogue suggests a potential shift in the regulatory framework for the commercial space sector. The combination of public concerns, congressional scrutiny, and possible changes to FAA policy presents a delicate balance between fostering innovation in the space sector and ensuring appropriate regulatory oversight. This dynamic interplay between SpaceX and the FAA is pivotal in determining the trajectory of Starship's development and launch schedule, influencing not only future missions, but also the broader future of commercial space travel. Starship reusability takes center stage. Flight 8 prepares for a historic attempt. SpaceX's preparations for Starship Flight 8 are heavily focused on achieving full reusability, a critical milestone for the company's long-term ambitions. The upcoming mission will involve a significant challenge, catching both the Super Heavy booster and the Starship stages, a feat that, if successful, would dramatically accelerate the frequency and reduce the cost of future missions. Significant preparations are underway for this attempt. Starship 34 and Booster B-15 are nearing the completion of crucial stages in their respective preparations, including cryogenic testing and engine installations. These milestones suggest the launch could occur sooner rather than later. The mission plans also include a full orbit return to the original launch site, adding to the complexity of re-entry procedures and potential challenges. The recent enhancements to Starship's landing system, particularly the foldable landing pins on later models like Starship 35, signal a focused effort on improving stability and durability during re-entry and landing. Detailed analyses and 3D models of the landing system are being developed, showcasing a meticulous approach to design and engineering. The incorporation of heat shield tiles to protect the landing system, as well as a slightly curved lower surface of the landing pins for better interaction with the capture system, highlight the attention to detail in ensuring a successful catch attempt. The modifications to the launch tower's lifting pins are also designed to accommodate the Starship version 2 and its revised landing pin design. These interwoven enhancements demonstrate a holistic approach to reusability, aiming to achieve a reliable and repeatable catch, a crucial component of SpaceX's vision for fully reusable spacecraft. The successful recovery of both stages during Flight 8 would represent a significant leap forward in space travel technology, potentially drastically reducing costs and enabling more frequent and cost-effective missions. SpaceX continues to press forward with preparations for Flight 8 of Starship, ranging from vehicle testing and launch site readiness. While SpaceX may have lost Ship 33 during Flight 7, Booster 14 was still caught. This outcome opens many possibilities for the combinations of vehicles that may fly and the possible objectives of the flight. SpaceX launched Starship Flight 7 on Jan 16 in another afternoon launch. The initial ascent with Booster 14 was perfect, with no engine outs and the hot staging maneuver completed. While Ship 33 began its ascent burn, Booster 14 completed its boost back burn minus a single engine and received the go for booster return callout. With it clear to return, Booster 14 then completed its landing burn with all 13 engines, including the engine that did not ignite for the boost back burn. The tower then caught it, making it the second Super Heavy booster to do so. However, Ship 33, the first Block 2 ship to fly, did not go well. During ascent, a fire can be seen coming out of the aft flap motor port, indicating a possible fire above the engine bay, shielding used to protect the aft dome during hot staging. SpaceX CEO Elon Musk said this was possibly a leak greater than the ship's vent capacity. Since Ship 25, SpaceX has had vents installed in this area of the aft section to help passively vent any leaked liquid oxygen or liquid methane out of the ship. Due to this issue, Ship 33's engines slowly started to cut out one after another as systems got damaged, much like with Booster 7 on Flight 1. Eventually, either the flight termination system was activated or there was an internal overpressure event, and Ship 33 experienced an anomaly exploding at a high altitude near the Turks and Caicos Islands over the Atlantic Ocean. According to the Federal Aviation Administration, FAA, debris then fell outside of the original hazard zones, which led to activating a debris response area to reroute or ground stop aircraft safely. Because of this and the anomaly, the FAA requires SpaceX to perform a mishap investigation into why this anomaly occurred. This flight is a setback for the Starship program as there were many systems SpaceX wanted to test on this flight when flying the first Block 2 ship. However, SpaceX has repeatedly proven that, as a company, the teams can solve these problems quickly and get back to flight. Regarding possible fixes for this failure, teams can add more vent capacity or, as Elon Musk said, add a fire suppression system to ship like a booster. Adding a fire suppression system to the ship could take some time as crews would have to add hardware to the ship and modify the tower and the ship quick disconnect to fill the ship with carbon dioxide. The ship may have been lost, but on the bright side, SpaceX did catch another booster, which is currently in Mega Bay 1, getting looked over and possibly refurbished for a second flight. Flight 8, Ship 34 and Booster 15. With the loss of Ship 33 on ascent, all eyes are now on Ship 34, which completed its cryogenic proof testing at Massey's just 2 days after Flight 7. The ship is now back in Mega Bay 2 to receive its aft flaps, engines, and other modifications before going back out for a static fire at Massey's. Ship 34's other half, Booster 15, is currently in Mega Bay 1 and just started receiving its grid fins within the last week. It is possible that Booster 15 rolls out for a static fire within the next week or two. Since Ship 33 was unable to complete most of its mission objectives, SpaceX will likely do another suborbital flight in order to test a Block 2 ship. If Ship 33 had completed all of its objectives, then it is possible that Ship 34 could have been the first ship to orbit with a possible catch attempt. The date for when Flight 8 is a big question mark. Currently, 2 parts will determine the date: vehicle readiness and regulatory issues. Using past vehicle readiness, Ship 34 could be ready by the end of February. However, assuming Booster 15 follows Booster 14's timeline, it may not be ready until April, but this doesn't factor in SpaceX making processes faster. The regulatory side is now more complicated than the last 3 launches because SpaceX needs to perform a mishap investigation and cannot fly until either the investigation is finished or SpaceX gets a safety exemption. Considering the FAA said debris fell outside the hazard zones and flights had to be diverted, SpaceX may have trouble getting an exemption. This means the sign-off for another launch won't happen until the FAA gives the go-ahead after SpaceX completes the investigation. Flight 9 and beyond. After Ship 34, we have Ship 35, which is only one section shy of being fully stacked. Assuming it gets fully stacked within the next 2 weeks, Ship 35 may not be ready until April or May. Regarding objectives, Ship 35 could be the first ship to orbit with a potential catch attempt on Pad B at Starbase, not Pad A. Here's where problems arise regarding vehicle combinations. Booster 16 is currently fully stacked, but was only finished a month ago. Based on the quickest booster readiness timeline, which is Booster 14 at 8 months, that would mean Booster 16 may not be ready for flight at the end of August. As always, these timelines use data from older vehicles, and SpaceX can speed up testing and booster outfitting. Still, assuming Booster 16 won't be ready for several months, SpaceX might end up reusing Booster 14 to get another flight in. Reflying the just second booster that landed wouldn't be unprecedented, as SpaceX did the same with the second Falcon 9 that landed. After Ship 35 and Booster 16, things get a lot more murky. Currently, Booster 17 is being stacked in Mega Bay 1, which is still a Block 1 booster. It is unknown if this is the last Block 1 booster to be made. Once SpaceX gets into Block 2 of booster, Pad B's readiness also comes into play in terms of hardware and on the regulatory side. In terms of ships, nose cones for Ship 36, Ship 37, and Ship 38 can be seen in various stages of production. With the possibility of booster reuse and ship reuse by the end of the year, vehicle combinations will be more challenging to predict.